We're just going to start off with some pretty basic solenoid questions. So here, 29.24 asks us, well, it says, a certain superconducting magnet in the form of a solenoid of length 0.5 meters can generate a magnetic field of 9 Tesla in its core when its coils carry a current of 75 amps. Find the number of turns in the solenoid. This is the equation we need. We learned this last lecture when we went over the theory from chapter 29. Isolate for n, plug in all your numbers. You get this number. You can pause it, do the math yourself. You get about 47,000 turns. Okay? So moving on, problem 29.26 says, you are given a certain volume of copper from which you can make copper wire. To insulate the wire, you can have as much enamel as you like. You will use the wire to make a tightly wound solenoid 20 centimeters long, having the greatest possible magnetic field at the center. So you really want a strong magnetic field here. You're going to be using a power supply that can deliver 5 amps here, and the solenoid can be wrapped with a wire in 1 or more layers. Should you make the wire long and thin or short and thick? Explain. The idea here is that if we make the solenoid, the copper wrapping, really thick, their spacing is going to be quite large. So that means we're going to get less turns within that 20 centimeter region, right? So that means that because L is set, all we can do is increase N. So we're going to make the wires very thin to have as many turns as possible. B says, should you make the radius of a solenoid small or large? The answer in the textbook is as small as possible to increase N. I'm not entirely convinced by that. I mean, you can tell me if I'm missing something super obvious, but if you wrap something really tight down like this, or if you wrap it like this, if you do it carefully enough and they have the same width, the wire itself, you're gonna get the same amount of turns out of it within that region. Of course, why would you necessarily want to do it super wide, crazy wide? Because then you're just using up a lot of copper wire. And while there is, not that much loss in copper, there is still loss in copper. So, you probably do want to make them as tight and small as you possibly can, just for both convenience sake and material. But that in itself doesn't necessarily increase N. So I'm gonna just remove that and put a little star here, because this question is a little bit ambiguous. The other ambiguity here is 1 or more layers. You're not really told what happens when you cross over the solenoid. So here, you can do this, and then you can wrap it again like this. Maybe that's going to increase your magnetic field inside here, right? They could definitely do that. So in that case, yes, you would want to make them as small as possible so that you can pile them up as much as you can. But of course, that's not so straightforward. And in this level course, you're not going to be calculating what's happening here. You're really only going to be looking at a very basic scenario. So here, there's some ambiguity. You can say you're going to make the radius as small as possible for a couple of reasons though.